find a unit vector in the same direction as this vector v. Now there's a couple things going on here. And number one is that this is the first time in these examples that I'm doing that we're seeing a vector written as a linear combination of the standard unit vectors I and j. Right? I, in 2 dimensions, the vector I is the vector 1, 0. Right? In 2 dimensions, the vector j is the vector 0, 1. So I could substitute for I and j here and turn this into a component form, which is the same and with which you might be more comfortable if you wrote it like this. But these are the same, and about half of the problems we deal with are written with the linear combination of the standard unit vector. So it should not surprise us. We should be able to work with both forms. Second, when it says a unit vector, unit means the same thing as it meant when we did the unit circle, right? The unit circle was a circle with a radius of 1. And so a unit vector is a vector with a length of 1 or a magnitude of 1. Right? The way you find a unit vector is you take the vector and you divide it by its magnitude. So how do you find the magnitude of a vector? Okay, you take the magnitude of v. In class we kept saying, do the Pythagorean theorem, which is kind of right. It certainly looks like that. 2 squared plus -3 squared. Right, I'm taking the square root of 2 squared plus -3 squared. And that is the square root of 13. Right? Please don't make the mistake of calling -3 squared -9. You know that a negative squared should be a positive. Okay. So now that we know this, then we're going to take our vector, which is 2, -3, and we're going to divide each component by the square root of 13. Oops. Right, that is a unit vector in the same direction as the vector that we started with. Right? I mean, you could also write it up here. You could have said divided by the square root of 13, divided by the square root of 13. And of course, you could rationalize denominators, but I'll count it in either case.